I got.
My entire group and I were having trouble with these, honestly. Like we were all talking about it. So yeah.
Same. I kind of get like 23 and 25. I can get halfway through them, but not completely till the end.
Okay.
Right. 23, 20, 23, 25. I did them all completely, but 35 and 37, it's like I got halfway through and then we had got stuck.
Okay. All right. Were there groups that did finish all of them, or how far did we get, like, for the other groups?
I just didn't get 37.
37. Okay.
Yeah.
Diana's group. I haven't heard from anyone in that group. Diana, Kathleen, Vanessa, Kanya. How far did y'all get?
Yes, I did. Yeah. I think I did all of them before. Yeah.
And Diana, Kathleen, Vanessa, y'all did all of them too?
I got halfway through. I got halfway through as well.
Okay. All right. So it sounds like we're going to be able to at least go through 35, and then maybe I'll send you back to go try 37 again once we've gone through 35. Maybe that'll help. All right. So we are on group 2. So Alondra, could you help start 23?
Yeah. I didn't do it exactly like how he taught us in the video, but like I don't know if I got it right. So like I just started by doing like x minus 6 equals positive negative 8, because 8 times 8 is 64.
Oh,
and then I
interesting.
made 2 equations, which one was x minus 6 equals negative 8 and x minus 6 equals positive 8. And then I got negative 2 and 14.
Okay, yeah. I mean, that sounds right from what you're describing. Oops, wait, I need a, oh no, that's right, yeah. Because then you added 6 to both of them. So you got u equals, you said 14?
Yes.
And then u equals negative 2? Is that the other
Yes.
one? Okay, yeah. Yeah, it sounds good.
Those are the real number, teacher, right?
It was u equals negative 2 and u equals 14.
Yes, we can say this, they are real numbers. It's not elementary, yeah. Or
Did
just
anyone else have questions? Because I know some groups said they were having trouble getting started on 23. So when we split them up, it's like we're taking this plus or minus and we're breaking it into 2 different equations, and then we're solving from there. One of them is the positive 8 and one of them is the negative 8. Any questions? No? Okay, all right, number 25. Next is Ashley. Can you start us on 25, Ashley?
Okay, I did my best. The first thing that I did was I had got the square root of m minus 6 and 20. And the square root of m minus 6 with the is m minus 6. And then I put equals plus and minus to 2 square root of 5.
Okay.
And then I end up subtracting 6 from both sides.
Oh, you subtracted?
I mean, I added 6 to both.
Okay.
Yep. And then that brought down my m equals 6 plus minus 2 the square root of 5.
Okay. All right. Now we can't simplify this anymore, which is the reason I'm not separating it. You know how on the last one, Alondra separated it into the 2 equations? That's because you could simplify it more. On this one, I can't simplify it anymore because I cannot add a non-square root with a square root. So I can't simplify it anymore. If you want to, you can split it into your 2 equations, but again, you can't simplify it anymore, so you don't really have to. Actually, probably shouldn't, just because you can't do anything anyways. You just get stuck right there anyways. There's nothing else you can do. But on the last problem that Alondra did, you could combine it. On the last one, we had an 8 and we were able to add 8 to 6, right? And we were able to do -8 with 6. We can combine those.
Okay, yeah. She had helped me like in our groups. That's what we was talking about. Because at first I thought I just supposed to left it as U equals 6 plus minus the 8, but she was like, no, you could separate it and stuff like that. So yeah, that part helped.
Mm-hmm. Yep.
In,
So I
in
just,
this problem, would we get like decimals? Like
if we were to continue, yeah, we would have decimals.
oh, okay.
Mhm. Yeah, I would want to see the answer like this though, unless the directions tell you to like find the answer and round it to a certain decimal or something. This is how it should be left for this
Yeah, 'cause
section.
that is an exact solution. If we do decimals, we're approximating. So if we're doing like the math, we typically want the exact solution. We might do decimals if we're graphing or if we're doing like a word problem. Those are like the 2 places where decimals will probably come in.
So if you see anything in the directions about exact, then you know for sure you have to leave it like this. But like Professor Seaver says, we're only really going to use the decimals if we're trying to graph it. Unless the directions say to, like if you're doing a word problem and in the word problem, you're trying to find like, I don't know, the profit or something like that, you wouldn't leave it like this because you have to put it in dollars and you want like an amount to look at. But for this section, for sure, we're leaving it with
Yeah,
the
you're-
radicals.
If your boss asks you for profit and you tell him 6 plus 2 root 5, he's probably going to be kind of mad, right?
Yeah. So word problems, we wouldn't leave it like this usually. And then if we're graphing it, we wouldn't usually leave it like this. All right, let's go to the next one. So the next person is Kayla. Can you start us out on 35?
Yes, I got the square root of both sides. And then was 5c plus 1 equals plus or minus. And then I broke up the -27 into 3i square root of 3.
Oh, okay. Okay.
Then I subtracted the 1 from both sides. And then I think divide both sides by 5.
Yeah. Now, typically when it comes to like imaginaries and plus or minuses like this, we write it like that. We don't usually write it as one big fraction, but you can. Do you prefer which one way or the other, Professor Severs? Do you want them to write it as 2 separate fractions or a single fraction? Or it doesn't matter?
I don't think I'm too picky at this
Yeah,
point.
that's what I was saying. Either way is fine. I'll write it the traditional way. The traditional way is just splitting it up like I'm doing here. But if you write it as one giant fraction, that's also okay. The reason I'm not a big fan of the one giant fraction is because a lot of students will reduce improperly when it's in one giant fraction. So that's why I usually split it.
And that's in standard form. That's why they go that direction. Because we have the A plus BI sort of thing happening there.
Yep, this is like we did when we first did imaginaries, the A plus the BI type of thing. The imaginary component is second and the real component is first. So that's how I'm just writing it. Any questions on that one? Because I know a lot of y'all said you were stuck on that one.
I had a question.
Mhm.
So I'm just wondering why we put the I in there, because like I is like square root of I is -1. So I was just wondering why we're putting that if we have the plus or minus in front of it, so it would already like change the
So
symbol.
the plus or minus has to do with the square root. The I is because it's a -27. So the negative inside is why we have the I, not the plus or minus outside has nothing to do with the I.
Okay, thank you. I was just wondering.
Yeah, no problem. Feel free to ask. Any other questions? No? Okay, then I'm gonna send y'all back into groups to do 37 because 37 is almost the same. The only difference on 37 is what? What do we have to do first on 37?
Subtract 11.
Subtract 11 first, and then it's the exact same process. Okay, so I'll put you back in groups so you can try it. because I want to make sure y'all can do it on your own a little bit too. So we'll go back and we'll do 37, and then we can start 75 also. Well, I'll put you in groups a little shorter this time since it's only 2. Alondra, we're back in groups. There we go. So I'll just write here same. So this is the same as this. Yeah, same thing. They're just writing it like extremely traditional, like how we traditionally write it. Okay. All right, any questions on this one before we move on to some factoring? Was it better the second time when you went back to go do it?
Yes, I understand. I understand it better now. 37 came better when I figured out how to do 35.
Okay. All right, good. Okay, so let's look at 75. And there's also a 5 there. So 75.5, I guess. Next is, who's next? Michael L. Did you start out 75, Michael L?
Oh, I didn't get to that. I was stuck on 37.
Okay. All right, we'll go to the next group. Joshua, what did you do for 75?
I didn't get to that one either. I was still working on 37.
Okay. Do you want to try to do it right now? Want to try it out?
Sure. I'm not sure how to start it.
Well, we want to get everything on one side.
Oh, right. So you're gonna subtract 3 from both sides.
Uh-huh. Because when we were doing our factoring, remember on that test, last test? Remember how we had sometimes something on the right and we had to move it over before we could factor?
Yeah.
Yeah. Okay. So could you try factoring it? Little throwback from the last test. What goes on the top of our X?
Read -3
Uh-huh. And the bottom of our X?
can be 2.
So what multiplies to equal -3 and adds to equal 2?
It's gonna get -3 or 3 and -1.
Okay, awesome. Yep, that multiplies to -3 and adds to a +2. So then we, whoops, split it up. Okay. All right, what can we take out of the first two?
U.
Okay. So you get U plus 3, and then what about the second two?
A -1.
Mhm. And it's good that they match. So now what?
You're gonna get the factors U -1 and U plus 3.
Now, do notice that I've been writing equals 0 on every single step. Don't forget your equals 0, because that's what tells you you're going to keep going. This is not an expression, it's an equation. So we have to keep going. So what do we do next?
U -1 equals 0. You're just gonna add 1. So it's gonna be U equals 1. And then you're gonna subtract 3. And that's gonna give you U equals -3.
Good. Now, I know on the test, there was a couple of people who tried to set it equal to 0 when it was not an equation, when it was an expression. So be careful. If it's an expression, you can't solve anymore after you factored it. If it's an equation, that's when you solve. So for example, just so you can see the difference, if this problem was instead this problem with no equal sign, and it just said to factor, then we would stop here because we can't do anything else. There's no equal sign. We can't do equals to 0. So just so you see the difference, because I know in the test some people switched, like solved it when you couldn't solve it. They went further than you could go. Okay. Any questions in this factoring review?
The solution, teacher, is 1 - 3, right?
1 and -3, yes.
Thank you.
I have
Oh,
a
another,
question.
Oh, go ahead. Yeah.
In the video for the notes, we had like x squared minus, sorry, they're testing my smoke alarms, but we had, in the video, we had a problem x squared minus 14x plus 90 equals -8. We moved the 90 over and then we did b over 2.
Yes.
Isn't that, I tried doing it like that on this one because I thought that's
B
how we were
over
supposed to do it.
2.
Yeah, we did b over 2, so we did 14 b over 2 squared, so we did -14 over 2 squared, and then it gave us -7 squared, which equaled 49, and then we added the 49 back into the
Yeah.
equation.
Okay, so you're doing completing the square. Are they doing
Oh,
completing the square here? Because this problem just says more properties. Do you want me to do
I
completing the
did the
square
same
with them?
thing. I used the same method. What
because I
profit?
tried doing it like that, and
Yeah.
I got stuck, and I
Yeah,
couldn't
no,
finish it.
that is a method. That's a way to do it. You can do completing the
Oh,
square here. I
okay,
just was
okay.
asking Professor Sievers if that's what we wanted to do here, because there's no directions here saying to do completing the square. So
Yeah, I'm not sure if the book might say specifically. I didn't look at the book, but
okay.
I know in
Well,
the notes, yeah, they were making them do these with completing the square.
No, not today.
I
But
assume
this
completing the
one,
square.
this specific one, you can do with factoring, so it's probably easier if you can factor it. I would like personally, like I'm gonna factor that thing.
Yeah.
It's way easier to factor it, right? Like if you can factor something, don't do completing the square. Completing the
Okay.
square really comes in when we get like square roots in our solution and stuff like that. When we
Yeah.
on things that we would typically say are prime. Now some of those things aren't going to be prime because we know completing the square.
So there's 2 ways you can do this,
Well, there's
completing the
lots of
square and
ways,
factoring.
technically. Yeah, but those are the
Okay.
two we're working on right now. Yeah.
Okay.
I'm gonna do it again then with completing the square because I didn't realize that that's what it was expecting you to do because there was no directions that said that. So I'll do it again with you with completing the square. So completing the square.
I was gonna say everything that we factor we can do with completing the square, but not vice versa.
Exactly. So a lot of times I see teachers when they first do this, they put like a plus blank on both sides so that students remember to add whatever you add to the left also to the right. So if you want to do that, you can. You don't have to write the plus blank, but some students prefer it. It helps them remember. So we're going to take our B term. Our B term in this problem is 2. So we take our B term, we multiply it by half. So that gives me a 1. And then we take that result, which is a 1, and we square it. So those are our 2 steps. We half the B, and then we square the answer that we got from halving the B. Now that number, this number here, that is going to be what we add to both sides.
Excuse me, teacher, I will stop you there a little bit. Because in this equation, we have ax squared plus bx. We don't have any c. For this one, and we need to find the c for our equation. For this one, we used c equals to b over 2 squared.
We don't need to find c if we're doing completing the square.
Yes, I mean, because I did the same method, but I found in the end, they have my results as 1 and -3. It's the same thing.
Oh yeah, you could factor this one. You could do completing the square. You could do quadratic formula. You could do it by graphing. There's like tons of different ways you can solve this problem. I'm just trying to show the completing the square method since that's what you're going to need on the next problem. On 81, y'all are going to have to do completing the square. So I'm just showing you how to do it. Yeah. So after you've halved your B, so you take your B and you half it, that answer you square, that is the number you're going to add to both sides. So I'm going to, in that blank, I'm going to put a 1 on both sides. Okay. Now we are going to factor the left. So if I factor that, it's going to turn out to be a perfect square.
Yes.
And then on the right, I just add it, just combine it. Okay. Now I will mention, if you happen to remember, this number is always what you get in your parentheses. This is always the number that's going to go here. Now, when you're doing whole numbers like this, it's not a big deal. But when you do fractions, factoring fractions is difficult. So let's say I halved like a 3, then I would have 3 halves. And then I'd square that, that's 9/4. Factoring with a 9/4 is very difficult. So something to remember is this number here is always going to be what's inside your perfect square. So if I had a fraction situation, it's much easier to remember how to do your factoring there because you don't actually have to factor it if you remember that that number goes in the parentheses.
Yes.
So it's at least it's easier for me to remember it that way when we do fractions. Okay, so let's keep solving because now it's the same as the last 4 problems we did. So now we're gonna square root both sides, right? Square root both sides, plus or minus. So then you get u plus 1 equals plus or minus 2. Now this is where Alondra had said that we need to split it into 2 equations because there's no radical. We can still continue to simplify. So this is where Alondra had done u plus 1 equals 2 and u plus 1 equals -2 and solved both. So u equals 1 is one solution and u equals -3 is the other. And hey, that's the same thing we got from factoring.
Yes.
And the same thing you would get from quadratic formula if you plug it in. Like I know some of y'all already know that about quadratic formula. All right, so this is called completing the square. So any questions on this process?
It's not so much of a question. I don't understand it at all. So with that being said, office hours is after or
yeah, we have some office hours after.
Okay.
Yeah. Yep. The biggest thing to remember is here we're going to half our b and then we're going to square that result, and that's what we're putting in our blanks. That's what we're adding to both sides. Once you do that, the rest of it will kind of fall out the same as the other problem. But I'll send you all back to groups to try 81 and 83 and 93 and see if you can get those going.
The 2 times 1/2, that's the 2 over b squared part, right?
Yeah, I do the 1 is always what's inside the perfect square. So I like to break it into 2 steps in case I have fractions, because then I'm like, oh, it's a 3/4 that goes in the fraction or whatever. It's just easier for me. But if you want to do it as b over 2 squared, you can do it that way. It's just if you get fractions, you have to factor them.
Okay.
So yeah, that's just my shortcut, my like trick to make my life easier when I run into fractions. So I'm not going to type the numbers in because we're just working on the last 3.
Yes.
Okay.
Yes, you can do it. Unmuted? No.
So we're going to take b, right?
Yes.
Going to do half of b.
Yes, I did. Can I do it, teacher?
Yeah, go for it.
Okay, so thank you, because I'm waiting for your answer.
Oh, I thought you said you were going to do it. I was waiting for you to do it.
Okay, thank you. Here I just put my b as 6. 6 over 2 is 3, and 3 squared is 9, right? And then I add my 9 to the both sides. And then it's going to be r squared plus 6r plus 9 equals to -11 plus 9, right? Then I moved my plus 9 to the other sides, which is going to be, r squared plus 6r plus 9 equals to -2.
You said,
then,
okay.
Yeah, because I just put -11 plus 9, it's going to be -2. Yeah. Okay. Then my equation, I just write it as r plus 3 squared equals to -2. Then I put everything inside of the square, which is square r plus 3 squared equals to plus minus square of -2. Then I put my square out, which is going to be r plus 3 equals to plus minus I square of 2. My 2 is inside of the radical. And then my final results is r equals to -3 plus I squared 2, and the other one r equals to -3 plus minus I square of 2.
There you go.
Thank you.
Cool. Thanks.
No problem.
Good. All right. Any last minute questions? Because I know we're at 1:40. Again, this will not be on your test, the completing the square part, just these 4, but the previous page, page 1, that is on your test. So any questions on 9.2? This is part of 9. This is the completing the square part.
I think for all the parts from 83 and 93, I used just b over 2. Yeah, it's the same method.
You do the same thing. Yeah, 83 and 93, the same thing. So it's handy to know, you know, if you have a kid that's in high school and needs help with completing the square, or your niece needs help with completing the square math, you can be the pro, go in and show them how to do it. But it's not going to be on the test. So
we're going to use it for other things, so I wanted to throw it out there at you just so you'd have some familiarity with it.
Yeah, it's used like when we talk about stuff, but you're not going to have to do it yourself. And it is used in higher math. So if you do plan on, for some reason, from now on taking another math class, you are going to need this. It's just that most people don't take another math class after Algebra Express. So that's why they removed it, because you use it after this class.
They created the class, and then a couple of years after they created it, they made a few edits and removed a few things from the class and stuff. And some of that stuff is still in the notes and still in the homework. So
yeah, they just removed this.
We got to try to remember which ones
All right.
are part of the core.
If there's no questions, then we'll see you tomorrow for the review for your test. Remember, your test is Monday.